So first of all, y equals ln of x is the same thing as e to the y equals x. Then you take the derivative of both. Then we get e to the y times f prime of y is equal to 1. This is because we know that the derivative of e to the u power equals e to the u power times u prime of 1. F prime of x is equal to 1 like any variable. Then we divide the right by e to the ln of x, which we know is just x. So now we know that f prime of ln of x is just 1 over x. So this is another important theorem of the section. We know that since f prime of ln of x equals 1 over x, then f prime of ln of u equals 1 over u times u prime. A mistake that some make is to panic when they see an absolute value sign in the equation, but it's simply the same thing, u prime over u. So in this example, the ln b on the far right is meant to be ln y. So to solve this, we want to expand the log e, and we want to separate it into the natural log of the top minus the natural log of the bottom. So then we use the earlier theorem that stated u prime over u is equal to the derivative of ln of x in order to create this equation. So here's another example. We know that this is equal to ln of 9x minus 2 to the 1/2 power, which we can then move down to the front of the equation. Now we have 1/2 ln, and then we use u prime over u to solve this equation, and we get 9 over 18x minus 4. So now I'm going to show you a common mistake with these larger problems involving logs and natural logs. So first you move down the 3 into the front of the problem, which is simple enough. Then you start to separate it, and you get ln of rad 15 x minus 2, or this can also be written as 15x minus 2 to the 1/2 power, which is pretty convenient for this type of problem, plus 3. Now, a common mistake is to distribute the ln to the 3 as well, and then subtract the ln of 2x. A simple mistake like this will make the whole problem wrong. This is why it is extremely important to only distribute natural log or log to parts of the equation being multiplied or divided, not added or subtracted. As you can see, the answer that you get when you make a simple mistake like this seems like it could be the right answer, but it's not. Now this is a practice problem involving maximums and minimums. So we have y prime equals 2x over x squared minus 9 from the u prime over u theorem that we learned earlier, and now we can solve for the critical numbers at when it's equal to 0 or infinity. Now I'm just making a really quick test value chart. I'm rewriting my derivative down at the bottom, And here I just plug in the test value to the top and the bottom of the fraction and look at what the sign is overall. Then when it goes from a negative to a positive, it's a min. From a positive to negative, it's a max. And then from a negative to positive again, that means it's a min again. So that's the relative extrema of the function. A common mistake in this type of problem would be to accidentally plug the test value into the original function rather than the y prime function that we found before the critical numbers. Do not do this. You want to find whether or not the slope is positive or negative, not the value. So here I'm just writing out the log differentiation steps, just a quick refresher. So now we're going to do an example using the log differentiation steps. Take the ln of both sides. Then we're going to expand ln of the right completely using the properties of ln and logs. Now we differentiate implicitly using the u prime over u for the y part, so we get y prime over y equals the derivative of the expanded right side. Now we just take the derivative of each section of the expanded right side using u prime over u theorem. Now we multiply by y to get y prime by itself. Then we substitute in the original equation for y and simplify. For the sake of time, I will leave that up to you. Now here are the formulas for the derivatives for bases other than e. Just a little review. Now we're going to try some problems. And here you just use the formulas shown in the previous screen in order to solve these exponentials without an e base. And this is the same without an ln. You can solve it using the last screen of formulas if it's a log. Finally, these are the power rule for real exponents, and here are some examples. You just use the different variables that it gives you in the formula and set them equal to different parts of the equation and solve. Thanks for watching.